In activity 7, we are told that fx and gx have the same remainder if they are divided by x minus 2, but we're not told what that remainder is. However, since we're dividing by x minus 2 and the remainder must be the same, it means that f of 2 must equal to g of 2. So we can calculate f of 2, we can calculate g of 2 and equate them to give us that a is equal to 3. In activity 8, we have to prove again that a plus b plus c is a factor of f of a. Again, if we look at a plus b plus c is equal to 0, and since f is a function of a, solve for a, it gives me that a is minus b minus c, which means we have to show that f of minus b minus c is equal to 0. So if we calculate f of minus b minus c, we see that indeed it is equal to 0, and hence that a plus b plus c is a factor of f of a. In activity 9.1, we are asked what should be added to function hx so that 2x plus 1 is a factor of the expression. Now, if you calculate h of minus a half, you will see that you won't get 0, which means that 2x plus 1 is currently not a factor of hx. So I'm going to define a new function fx, which is hx plus some or other constant, and that is the value which must be added so that 2x plus 1 is a factor of fx, which means that f of minus a half is equal to 0. So, if f of minus a half is equal to 0, we can calculate f of minus a half and equate that to 0, and when we solve a, we get that a is negative 23 over 8, which is negative 2 and 7/8. So that means we have to add negative 23 over 8 to hx so that 2x plus 1 will be a factor. In activity 9.2, we're asked what is the graphical explanation of your answer in 9.1 with respect to function hx. Now, hx is a cubic function, and clearly x equals negative a half is not an x-intercept of h, which implies that, again, 2x plus 1 is not a factor of h. So basically, what we were asked in 9.1 is what should we do to function h so that 2x plus 1 is a factor, which would imply that x equal minus a half is an x-intercept. And that means we have to move the function down by a number of units in order for x equal minus a half to be a factor. And that number by which we have to move it down is that we have to move it down by 2 and 7/8, or move it down by or add negative 2 and 7/8 to hx. In activity 10, we're asked to prove that if x plus p is a factor of tx and p is not equal to q, prove that p squared plus pq plus q squared equals 0. So if we're told that x plus p is a factor of tx, then it means that t of minus p is equal to 0. If we now calculate t of minus p and equate it to 0 and simplify, we get that 0 is q cubed minus p cubed, which is the difference of two cubes. We can factorize q cubed minus p cubed as q minus p times q squared plus pq plus p squared. Since we have the product of two things is equal to 0, one of these two factors must be 0. But we were told that p is not equal to q, and therefore q minus p cannot equal 0. And hence, q squared plus pq plus p squared must be 0, as q minus p cannot be equal to 0. In activity 11, we're asked if ax plus b is a factor of fx, prove that 2b cubed plus 3a squared b squared plus 2a cubed is equal to 0. So again, if ax plus b is a factor of fx, then f of minus b over a is 0. So if we calculate f of minus b over a and equate it to 0 and simplify, multiplying both sides by a cubed, we can prove that 2b cubed plus 3a squared b squared plus 2a cubed is indeed equal to 0. In activity 12, we are told that if gx is divided by x minus a, x minus b, then the remainder is given by cx plus d. So note that in this case, we're not dividing by a linear factor anymore, but by the product of two linear factors, which is actually a quadratic expression. So if you divide by a quadratic expression, then your remainder will not necessarily be free of x, but it must be of a degree lower than a quadratic expression, and therefore of the form cx plus d. And we can therefore write that gx is x minus a, x minus b times px plus cx plus d, where px is my quotient and cx plus d is my remainder. So if we're asked to determine c and d, where 2x cubed minus 11x minus 5 is equal to 2x minus 1 times x plus 2 times px plus cx plus d, we can see that 2x minus 1, x plus 2 is my divisor, px is my quotient, and cx plus d is my remainder. If I now do long division with 2x cubed minus 11x minus 5 and the divisor, that will give me the quotient and the remainder. But we cannot divide by 2x minus 1 times x plus 2 in that form. So we first have to determine the product, which will give me that 2x squared plus 3x minus 2. So we're going to do long division, dividing 2x squared plus 3x minus 2 into 2x cubed minus 11x minus 5. And note that we have to put in a placeholder for the x squared term. So 2x squared goes into 2x cubed x times. If we multiply that out, it will give me 2x cubed plus 3x squared minus 2x. If we now subtract, we get minus 3x squared minus 9x minus 5. Since the degree of minus 3x squared minus 9x minus 5 is still equal to the degree of 2x squared plus 3x minus 2, we have to do the process again. So 2x squared goes into minus 3x squared minus 3 over 2 times. If we do law of distribution with minus 3, that will give me minus 3x squared minus 9 over 2x plus 3. And if we subtract correctly, the result is minus 9 over 2x minus 8. Since minus 9 over 2x has now a degree less than 2x squared plus 3x minus 2, it means we have completed the long division, and minus 9 over 2x minus 8 is my remainder. Now we were asked to find c and d, where the remainder is cx plus d, so that simply means that c is negative 9 over 2 and that d is negative 8.